Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, the final lecture on two-factor ANOVA, we will talk about moving into testing model pairwise comparisons for model testing once we have concluded that we have some main effect in our two-factor ANOVA. So again, here's the flow chart that we've seen a few times before that gives us the model testing steps. And this is where we move into testing pairwise comparisons. So if you test the main effect of one predictor and the main effect is not significant, then you stop and you don't go on to test pairwise comparisons. You conclude that that factor was not a significant predictor of the outcome. But if you do find a significant main effect, as we just did looking at the component F test for violent video game condition, the video game condition, then we move on to pairwise comparisons or two-group comparisons. And we've talked about pairwise comparisons already a little bit in one-factor ANOVA. So with pairwise comparisons, regarding our two-factor ANOVA example, we know thus far that only the video game condition main effect was significant. And so the next step is to compare every pair of conditions in the video games. That is, compare every pair of means. And as I described with one-factor ANOVA, these pairwise comparisons use the same independent samples t-test from one-factor ANOVA. And it's a modified or adjusted independent samples t-test. Something new that we can look at is something called the standardized mean difference. And this is going to give us an effect size that characterizes the size of the group differences in a standardized metric, not the raw metric. So let's take a look again at these profile plots of the estimated marginal means of aggression across video game condition. So we have the control group, the nonviolent game group, and the violent game group. And again, just kind of eyeballing these, visual examination shows us that the violent video game condition marginal mean seems to be a little bit higher than the control or the non-violent game conditions. So now we can look at these pairwise comparisons for the different conditions. And these are what plots of these pairwise comparisons would look like. And we can see the associated p-values here as well. So when we look at the control versus the nonviolent condition, the p-value associated with this mean difference is 0.454. So there's no significant difference between the control and the nonviolent condition. When we look at the control versus the violent condition, the p-value is 0.001. So there is a significant difference in the control between the control and the violent conditions, such that kids who play violent video games have higher levels, display higher levels of aggression than kids in the control condition. And then for the nonviolent versus the violent conditions, the p-value is also significant. So it looks like kids who are playing violent video games are displaying higher levels of aggression than kids who are playing the nonviolent video games. And here is where we would find those mean differences and the significance values in the SPSS output. It's in this multiple comparisons table. You know we have to request this table. And I've highlighted here in pink the boxes that give us the information, and you know the boxes outside or the information outside of these pink boxes is redundant information. So they basically provide us with all of the information that we need. Too much of it, actually. They kind of double up on the information by just showing us all of the pairs across all of the possible combinations. Okay, so what conclusions we're going to make having gotten to this point of the model testing in that model testing flowchart is that the significance tests and the marginal means suggest that the violent video game condition produces significantly higher aggression scores than both the control and the nonviolent conditions. The control and the nonviolent group were effectively identical because there was no significant difference between them, with any observed differences likely due to sampling error. So now that we've reached this conclusion, we can use the standardized mean difference effect size to get a metric, an effect size for a metric-free effect size for these mean differences to understand the magnitude of them and putting them in standard deviation units. And so in order to get the standardized mean difference effect size, we take each mean difference and then we divide it by the average group standard deviation, which is going to be the square root of the mean square error. And for this effect size, the reason that we do this is we like to have these effect sizes that are kind of not in the original metric, but are in standard deviation units, allowing us to think about this in terms of the normal distribution. And these effect sizes allow us to convey kind of the magnitude of an effect size using some established guidelines. And so there are actually established guidelines, some cutoffs for the standardized mean difference as well. And so the standardized mean difference effect size guidelines, negligible is anything less than 0.2. Small is 0.2 to 0.5, and moderate would be 0.5 to 0.8. And then a large would be anything above 0.8, 0.8 to 0.1. This concludes the last lecture on two-factor ANOVA. And in the next series of lectures, we will discuss ANOVA and interactions in analysis of variance framework.